Okay, good morning again. This is Cameron Van Dyke with the Washington Self-Insured Association. My apologies. Technically, I'm having a few difficulties on the video side due to internet at my home. Today, we invited Gary Anderberg, who actually helped start workers' compensation in the turn of the last century. I'm kidding, Gary. I've met Gary at a conference earlier this year and was very intrigued by his questions and how he interacted with some of the keynote speakers. Also, one of our own Washington Self-Insured board members highly recommended Gary. So with no further ado, Gary, I really don't want to try to introduce you any more than that. So you take it away. I'm going to be monitoring the chat, everyone. Gary's got about an hour or so of content, and I'll be looking at the chat function. And I think this should be a really, really great presentation. So Gary, take it away.
Hi, this is Gary Anderberg. I am the senior, as in very senior, vice president of analytics for Gallagher Bassett, the big third-party administrator. And I have been doing this for a long time. I wasn't actually there when the first workers' compensation claim was filed, but I know the people who were. So what I want to talk about today, because everybody is very interested in the subject of what is the impact of artificial intelligence on claims. I've called my talk here Artificial Intelligence and Real Claims, a Synthesis. And we're going to take a look at three particular ways in which artificial intelligence and claims can interact. But let me start off here with a little bit of an introduction to what we're talking about with artificial intelligence. AI actually has been around long enough that it comes in flavors, that it has a history. This is no longer brand new. What we're going to be talking about today is large language model AI. This is the type of AI of ChatGPT, which has become sort of the poster boy for modern AI. I'll talk a little bit about where AI has come from and how it has been developed in our part of the industry. But what I want to talk about is the important thing to understand specifically about large language model AI is that it's not just another application tool. This allows us to go places we haven't been able to go before. It allows us to ask questions and answer them in ways we have not been able to do before or not been able to do with any facility. In other words, it enables us to look at new approaches to how we handle claims and maybe to solve some of those kinds of pains about handling claims that we've been so used to we almost don't even notice them anymore. So the three cases I'm going to take a look at is what can large language model AI do for us about how we handle claims correspondence? Pardon me. How can AI be the adjuster's best friend? And hey, what about claims notes in English? We'll talk about that. I think you'll find that interesting. And finally, to talk about AI leading us to better jobs, not fewer jobs. I'll tip my hand right here. I don't see AI as a way of thinning our ranks, quite the opposite. It allows us to do things better and to do things perhaps with greater granularity than we've been able to do before. But I think it's going to be a boon to everybody. After we get through what will probably be an awkward little adjustment period. So let's just take a look at where we've come from. Machine learning AI, that's what people were talking about when they talked about artificial intelligence 10, 12 years ago. Machine learning is essentially a math-based form of AI. And large language model, as the name suggests, is a language-based AI. It works quite differently. Machine learning AI looks at large blobs of data, the proverbial big data, and it looks for patterns. It looks for if this happens and this happens, then there's a good chance that will follow. So as a quick example, looking at a claims application, this was something I did, at this point, probably 12, 13 years ago, was asking the question, can we predict which workers' compensation claimants are most likely to litigate given the chance? Who's got the propensity to litigate? If you talk to a lot of veteran adjusters, what you would find is that everybody has some idea of what they would look for. Here's a claimant that I think is going to lawyer up. And we would come up with about 5 or 6 indicators. But when we actually did a mathematical analysis looking at actual relationships on completed claims of initial states, i.e. the initial metrics of the new claim, and whether or not legal representation became involved, we found actually 33 indicators. Some were very strong, some were weaker, but all were significant indicators. We built a system combining all 33 of those, and we came up with a very, very reliable predictive system that you could go to the bank on. When we looked at a claim after it had been open for 2 or 3 weeks, we could say with a pretty fair degree of certainty, if we do not intervene, this claimant is going to lawyer up. Pretty reliable at that. I used to scare people, because I built these things, I used to scare people by saying, now, if I have enough information about you, I can say Gesundheit 10 seconds before you sneeze. It's always fun to watch people's faces when I say that. But that's really the essence of machine learning AIs. It's highly predictive, but it's predictive based on mathematics and relationship of data elements that form certain patterns. Now, ChatGPT works on language. We'll talk more about that in a moment. And ChatGPT is just the beginning. That's gotten the headlines, but there are actually quite a few large language model AIs out there. And ChatGPT, by the way, has several flavors. It's not one thing. There's a version of ChatGPT that, for example, is very good at coding. You can ask it code a sequence that will do such and such when the initial conditions are so and so, and it will write the code for you. It will give you a nice chunk of code that you can drop into an application. There's another one out there that I'm very fond of, my friend Claude 2.0. Claude 2.0 is a large language model AI built by a little company called Anthropic, which is in the process of being purchased by Amazon, by the way. That should tell you something right there. One of the things that is striking about Claude is Claude has a somewhat different design than ChatGPT. When I was putting Claude through his paces, I had him examine and summarize and so forth many, many different types of prose. I had him take a look at complex graphics, for example, and turn those graphics into a written summary in no more than 400 words, for example. He did that extremely well. So I kept poking at Claude, wondering how far can Claude go? So I tried an experiment. I asked Claude to read a short story. Now, this was not just any short story. My hobby, by the way, is writing short stories and novels. I'm happy to say that my Western, The Winter of Wolves, is currently available on Amazon. That's the limit of my plug for that one. But I asked Claude to read a short story I had written called Death Certificate. Death Certificate is a moment by moment, as detailed as I could make it, account of what it is like to die. Because I'm one of those people who died and was brought back. Yeah, I've been to the other side, and by the way, it's not a ticket you want to get right now. So I asked Claude to read that story and to tell me what it thought. And I'll give you just a couple of sentences from Claude's reaction to that story, Death Certificate. And think about, as I read this to you, think about the fact this is written by a machine reacting to a story it's never seen before. The man's frantic fight to cling to life is vividly conveyed through sensory details and internal dialogue. His resurrection highlights the resilience of the human spirit and drive to survive against seemingly impossible odds. The passage provides a dramatic perspective on the confrontation with mortality and the primordial struggle to stay alive. That's a machine talking. It's a machine talking about the struggle to stay alive. That should indicate to you that with large language model AIs, we're in a new world. This is not what we're used to computers doing. And we'll talk about what that means and some specific applications in a few minutes. One of the things I wanted to mention right up front, by the way, is AI and privacy. All of us in claims are keenly aware of PII. And so one word of warning right now for anybody who wants to go out and play with their neighborhood artificial intelligence, it takes some doing to make certain that we do not violate PII or other confidentiality rules in working with large language model AI. It was not initially designed to understand that there are things, that there are details in a file that it might be dealing with that can't be revealed under certain circumstances or to certain users. So one of the things that we're working on right now is building domains and access routines inside our own chat GPT at Gallagher Bassett. We own a version of Microsoft very thoughtfully built for us, to make certain that we don't accidentally violate any privacy consideration. So I just wanted to put that up front. With old-fashioned machine learning AI, that was pretty easy to do. It requires a very different approach with large language models. As I mentioned here, what we're dealing with is words, words, words. Large language model really looks at language structures. It looks at how meanings interlock and interact and how one set of meanings tends to or has a propensity to relate to another set of meanings. It's working with words the same way we're used to earlier applications working with numbers. And that is a huge difference. That's what I call solving the unsolvable, because there have been so many issues that we wanted to address in claims that metric-based models, that is, models of applications that require very specific hard data to work from, simply couldn't address. Large language model allows us to solve the unsolvable. It allows us to hack the text boxes. Now, I'm sure most of the folks on this call work with claim systems on a pretty regular basis, probably more than you want to some days. Text boxes I define as the place where the most valuable information in the file goes to die. Because in a conventional claim system, information in text boxes, which can be absolutely vital to what's going on with the claim and how it's likely to resolve, and et cetera, et cetera, et cetera, is totally unavailable to any conventional reporting because it is unstructured data. Large language model brings us potentially to the end of what I call don't ask. That is, don't ask because we can't go there. It allows us to ask and answer a lot of questions that up until now have been kind of a blank wall. New solutions demand new questions. The most important thing to know about large language model is it can answer the questions we've been told not to ask. All of those things that we've been saying, isn't there some way we could find out such and such? And I'll give you some very specific examples in a moment. And our system architects, our programmers, our IT professionals would say, well, that requires understanding unstructured data. We don't have data points that address those issues, so we really can't do anything with that. So I want to emphasize it's not a better way of solving the same problems we've been wrestling with. It allows us to address issues we are so used to that we may not think of them as problems. And what that means when we start talking about large language model AI is throw out the old boxes. Don't think along the old lines. Don't be concerned about, oh, we tried to do such and such 5 years ago and we couldn't get there. Don't think about that, because it allows us to do things that weren't possible before. So here's the 3 examples I want to talk about today and get into a little detail about what that really means. What if every new piece of claims correspondence arrives at the adjuster's desk already vetted with a relative priority and response date noted and logged in something like a time-sensitive log, for example, before the adjuster even sees it? That, in other words, this new correspondence has been what I call pre-chewed. It's been already gone through a process where we understand what's there. We've got a little note tag to the top of it that gives the adjuster a précis of what this is and how we need to deal with it and what its relative priority is relative to other claims tasks we're looking at that day. Would that make a difference in how we handle claims? Yes? Question?
Yeah, this is Cameron. Just interjecting really quickly. Are you going to be sharing a screen or not? Sometimes people share their PowerPoint. I'm not sure if you were intending to do that or not. Either way, it's fine.
It says here I'm sharing my PowerPoint. Aren't you seeing it?
I'm not. So,
Here.
Carrie, can you tell me just a second?
Because I got it on share, and I assumed everybody was seeing it.
Are you using multiple screens, Gary?
Pardon?
Are you using multiple monitors?
Yes, I am.
That's the problem.
Sorry, everybody, about this.
I didn't realize that was going to be an issue.
No
Sorry.
worries. No worries at all.
Well, there's no illustrations. There's just words. So
okay,
I will thunder ahead with the words. And if anybody would like to see what the actual slides look like, I'll be happy to provide copies.
Absolutely. And some of the people in the chat are saying they can see the PowerPoint. So perhaps it's a limit on my side. So Gary, keep going.
Okay. So that's my example number 1. My example number 2, my test case is, what if any adjuster confronted with an unusual and or complex claims problem or return to work situation could pull up an inquiry box and enter a natural language inquiry for expert assistance? And I'll give you an example in a couple of minutes on how that would work, how AI can now make everything that the whole claims department knows available to an individual adjuster handling an individual claim right here, right now. What if claim notes were translated and formatted in standard English as the adjuster enters them, making all those notes easily readable with no obscure abbreviations or arcane adjuster jargon? And in a few minutes, we'll be talking about what language are your claim notes written in. Sometimes it's not English. So let's talk about incoming claims mail. I call that surfing the tsunami. I don't know about your claim shop, but I know we we get claims mail by the long ton. I mean, thank God most of it comes in electronically. Otherwise, we'd have 18-wheelers backed up at the loading dock all day, every day. But we're getting these huge volumes coming in. The amount of correspondence per claim certainly seems to be going up, particularly with complex claims. And when we talk about claims, remember, of course, that I'm talking here primarily about our more demanding claims. Lots of claims are the simple little things that a recent high school graduate with a simple little program could take care of easily. I'm talking about the 20% of claims that make us say, wait a minute, what the hell's going on here? So how do adjusters keep current on incoming new mail? Because you've got issues you have to be looking for, like legal demands. Did somebody just lawyer up and this is why you're finding out? Response deadlines. Many states, when we're talking about workers' compensation, you have 15 or 30 days to respond to something, and otherwise there's a penalty that attaches. We're talking about voluminous attachments. Our adjusters are constantly getting innocent, sweet little one-page emails that have 30-page attachments trailing along behind them. And we're talking about the question of relative priorities. How do I know which one of these things I need to hop on first? How is this new piece relative to all the other new pieces? How do I allocate my time? Now, in the past, and probably many of your claim shops do this, we've used things like keyword searches to try and look for, does incoming mail have the word lawsuit in it? If so, flag that so we'll take a quick look at it right away. Unfortunately, keyword searches tend to give us a lot of false positives because it's a very crude tool. And particularly when you have a whole string of emails on a given claim, and the first one mentioned lawsuit, and then each one of them copies that. So you've now got 10 emails, every one of which has the word lawsuit in it, and your keyword search throws up all 10. But there's really only one that's at issue that you need to take a look at. Here is what we're looking at right now. And this is not, by the way, something that's going to happen. This is something that's happening right now. What if your large language model AI reads all of the new mail and vets it across process control categories? How could this improve efficiency and compliance? In other words, your large language model AI, which has been trained on tons and tons and tons of your claims correspondence, so it knows exactly what it's looking at. And so it knows, for example, that a California form number such and such has a 15-day response window on it. It knows all that. It reads the incoming mail, and that's very important because you may have a letter. We just love it when we get letters from attorneys because sometimes the letter includes a demand, and sometimes the letter starts with a demand, which is proper form, but sometimes the letter doesn't get to the demand until the very end, which means if you don't read it down to the very last word, you don't realize there's actually a demand with a legally required response included in that piece of correspondence. So if the AI is reading all of these things and it's been trained on our correspondence and it knows what's sensitive and what is not, what is high priority and what is low priority, what has a 15 or 30 or 45-day response window, it can detect and label all of those things with a very, very small level of false positives so that that information is attached to the new piece of correspondence when it pops up on the adjuster system. As I said, this is not something that we're thinking about. Two fairly good-sized regional insurance companies have been doing that for the last couple of years. This works very, very well. Now, it takes a little work to train the system on incoming correspondence, and you have to train it separately on each line of coverage because workers' comp claims work differently than transportation liability claims work differently than fire property claims and so forth. But once you've done that, the system takes a look at this, in a matter of seconds. I hasten to add, it takes virtually no time to do this. Takes a look at that new correspondence and all of its 30-page attachments and says, okay, here's what you've got. This goes on the time-sensitive log. You've got 30 days to respond to this, and this is a #1 priority. How does that change your job as an adjuster? We think that allows us to do a lot of things better with less wear and tear on everybody. So there's an example that's already in place. A few companies are already doing that. It's brand new, but it's been in place long enough, 2 years in one case, where we know it works. It's been pressure tested, as it were. It's been tested under fire, and it works very nicely. So let's talk about your best claims handling buddy. Most claims are routine, but some are complex and surprising in new ways. And let's combine that with something else. Across the industry, this is everybody, carriers, TPAs, self-administered employers, the core of veteran adjusters is retiring. Now, by the way, I flunked retirement 12 years ago. And but I understand there are people who actually like it. I lasted 6 weeks, and I was on the phone calling everybody I knew saying, get me out of here. But more and more of our veteran adjusters are retiring, and more positions are being taken by adjusters with relatively limited experience. In fact, this year, right here, right now, is the high point of baby boomers retiring at age 65. And in another 5 years, the baby boomers will be, those who retire at 65 will basically be out of the workforce. So this is important, and it's right here, it's right now. So what if you could take all of your documented claims how-to expertise accumulated over the most recent, say, 10 years, and place it in a limited purpose, what's called a corpus, which is the information receptacle, as it were, inside a private large language model AI application. In other words, everything, all your manualizations, all of your notes on how you handled unusually complex return to work situations, et cetera, et cetera, et cetera, all of this is in a big data repository inside your large language model, and it's read and understood all of this. Now, what if the adjuster facing a novel set of claims issues could simply type into an inquiry box going into addressing the AI, how do I comp claim in Indiana when the primary ICD is and get a set of instructions based entirely on your own vetted and approved claims adjusting manuals and standards. And that's an important piece. We're not talking about going out there to anybody and everybody. We're talking about a database that's based on your organization's own standards. This is how you do things. So these responses are unique to your systems. So I'm an adjuster, and I'm looking at something, I'm thinking, oh, what am I going to do about this? So I type into my AI inquiry box, how do I handle a return to work project for a 48-year-old machinist who has just had a shoulder reconstruction on his dominant arm, and by the way, he's a diabetic and he's overweight. Oh, and he smokes. How do I do this? And the AI takes a look at everything it knows about all the claims like that you've ever handled, and it says, here you are. This is what you do. Would that be useful? Because in effect, it makes everything your organization knows about handling claims immediately available at the touch of a plain language inquiry. It's all there. So that's something that's in the process of being developed right now. This is not pie in the sky. This is something that large language models, in fact, are very good at. Here's another one. This is what I call the say what. For many or most purposes, the most important information in a claim file is posted in those blankety blank text boxes we call adjuster notes. Now, I have been reading adjuster notes for many, many years. And every now and again, I'm pleasantly surprised and I come across adjuster notes written in something that resembles English. Most of the time, they're in something else. And I never know, some adjusters write extremely brief notes where I have to try to guess what actually happened because I've only got a couple of highlights. We have other adjusters who, like me, want to be a novelist. And so we have an adjuster note that begins, "It was a dark night out on the moors and wolves hollered in the distance when Mr. Smith was injured while working on his such and such." We have everything. So what language are your notes written in? We have lots of codes that are known only to adjusters. One place I worked, we discovered that each claims office, and we had about 50, each claims office had its own idea of their standard abbreviations, which didn't match anybody else's. That was fun. We have all these private abbreviations. Adjusters come up with little 3-letter things that mean something to them and not necessarily anybody else. But this is a term they have to use often, so they just go plunk it in and move on. And then as we try to read it, we're trying to figure out what the hell happened here. You have sentences which are not sentences. And you have things like unclear antecedents, like who did this? This happened to what? What part was it? Which diagnosis was involved? In short, how easy are your adjuster notes to read correctly and understand completely? Remembering that sometimes you're going to be reading those adjuster notes with your client who takes a look at the adjuster note and says, "What the hell went on here? Explain this to me." So what if you had a large language model AI translator, which has been trained on all of your claims notes jargon, which has looked at everything any of your adjusters have written in claims notes over the last 3, 4, 5 years, and understands what's going on there, what these little abbreviations mean, what these codes stand for, which can then rewrite every note as it is written in real time into standard business English, which is eminently readable by anybody. How helpful might that be? Would that be a useful thing? I mean, from my experience in going over actual claims and reading adjuster notes with sometimes fairly picky clients looking over my shoulder, I wish I'd had one of those 30 years ago. So that's another thing that a large language model can help you with. And that's why we call it, that's why it's a large language model. It's very good at being, why I put translator in quotation marks. We're not talking about going to German to English or whatever, but taking jargon that is used all the time, anywhere from codes to private abbreviations, which the adjuster uses repeatedly, figures out what they are because it's trained on them. And then as the adjuster can just type as they will. They don't have to learn anything new. They just sit down at their keyboard and wail away. And the system is saying, okay, I know what that means. Okay, this code stands for such and such. I plug that into that. When we get to the end of it, we have a standard business English note that anyone can read, that of course is discoverable for legal purposes, et cetera, et cetera. How helpful would that be? How much, what the hell does this mean, might that save us from? So that's another thing that we're working with right now. And I might mention, by the way, that I just picked these 3 things because they apply very specifically to claims, but each one of these things has analogs in other aspects of what we do in insurance and claims administration. So for example, I talked a bit about providing instructions for adjusters that they can go to and say, I've got a difficult claim here. How do I handle this shoulder repair, such and such, the example I gave you a few minutes ago. That can be applied in other places as well. Let's say you have a large, complex software system. One of the things you can do is you can take all the manualization for that software system, everything you develop, both the general manualization and the special instructions have been developed. You can do the same thing with that in terms of create a corpus of everything we know about specific to our system. This is how our system works. So then when somebody says, oh, wait a minute, there's 58 different reports I can run and I'm forgetting, I can just go to an inquiry box and type in, how do I run a report that shows closed claims for the last 3 years at these 3 locations with values over $10,000? And the system takes a look at it, here's what you do, here's where you go, here's how you run it. So that concept, in other words, is applicable to a whole bunch of different situations, making some of the things that historically have been a problem in our industry. We have an ongoing problem with software because has anybody seen a software system get simpler recently? I haven't. They all get more complicated because they all get more functionality. And as they get more functionality, learning what that is, particularly if you come to it new, becomes almost insurmountable. It's like, you're all of a sudden you're looking at the Great Wall of China saying, now what do I do? So this has any number of applications to make various forms of information infinitely more accessible to users, whether it's vetting incoming claims mail, whether it's helping an adjuster get the information they need to handle a complex claim, whether it's a client reading a claim file and actually understanding, gee, I realized what happened here. All of these things are things that large language model can help us with. And the overarching purpose of the 3 concepts that I've discussed here, and I hope this is obvious, is not to eliminate adjuster positions. Our objectives, as we're implementing this and developing these things, are very particular. First of all, better consistency in the work product. So when I talk about claims correspondence coming to you vetted with time-sensitive logs already set up and entered and so forth, that means the chances for an adjuster missing a deadline go down. You could still do it if you really were dedicated to the proposition, but in most cases, we're going to find fewer instances of those annoying little fines, for example, with California work comp. You were 3 days late on filing this, and that's a $25 fine, all that kind of stuff. But the most important thing is improved decision support for adjusters. One of the things that I specialize in is what I call decision support systems. When I arrived at Gallagher Bassett over 10 years ago, they actually recruited me when I was 67, and being an object of desire at the age of 67 is just wonderful, by the way. I asked the folks in the C-suite, I said, okay, you're a big, sprawling, top-line claims administrator. What is the product that you sell to your clients in one word? No word clouds, no no some of this, some of that. One word. As a third-party administrator, what do you sell? One word. Oh my good heavens to Betsy, talk about deer in the headlights. And so I let them struggle for a moment, and I told them the answer. The one thing that as a claims administrator we provide to our clients is decisions. We are a decision engine. And the quality of our product for our client is the sum total of all the decisions each adjuster makes on each claim every day. There's nothing else. It's decisions. It is the aggregate of the decisions we make that determine did we or did we not do a good job for our client? Did we control claims expenses correctly? That's all a matter of decisions, making the right decision. So one of the things that I've done for many years, my current position and before that, is building decision support systems. These are various types of applications, nowadays using large language model, but using other types of application structures before that, that help the adjuster make better decisions on the problems that are confront us with our claims every day. That's the most important thing that we can do in terms of building the systems, because otherwise, a claim system is just a big accounting system. That's all it does, except for all the decisions the adjuster has to make. How do I help the adjuster make the right decision, particularly on a complex claim? Decision support is something that large language model allows us to take to a new level. We've been doing that for quite some time, but this allows us to do even more in that very, very key area. And it also allows us to eliminate some measure of the tedious detail work to allow adjusters to focus on the high value portions of the claims task. What are those high value parts of the task? First and foremost is actually talking to claimants. Lots and lots of research has shown that, again, we're talking about non-routine claims. This is not the see the claim, pay the claim little $200, $500 claims. Talking about the more serious, complicated claims. One of the most important things you as an adjuster can do is talk to the claimant, understand where they are coming from, help them understand what the claims process is. Because in most cases, most claimants haven't been this route before. They're scared. One of the qualifications I have for working with claim systems is that back in 1989, I had a potentially career-ending workers' compensation claim. And I was in an airline accident on company business. It was not fun. Doctors said, "Oh, we don't think you'll ever walk again," among other things. They turned out to be dead wrong, by the way. But that gave me the experience of seeing a workers' compensation claim from the other end of the process. And I knew the process very well. I'd worked with building workers' compensation claim systems, and I still found it a strange and scary place to be. I was a professional who knew the lingo. And I still found it, what the hell is going on here? Well, when am I going to hear from my adjuster? Well, how are they going to handle such and such? The most important thing you can do with your time as an adjuster is to interact with claimants. Help them understand the process, help you understand where they're coming from. What are their issues? How can you make the process work better for them? That's the most important thing you do. The next most important thing you do is thinking through best problem solutions. Because, again, complicated claims, not to see the claim, pay the claim, complicated claims may have several possible alternative ways of approaching them. Which one is the best? You need to have, as the adjuster, you need to have the time to think that through. You need to have an AI at your elbow that can help you think that through. But, one of the things that, if we're running a claims department correctly, one of the things that we understand is, what do we pay adjusters for? We pay adjusters to think, damn it. We want them thinking. We want them to have the time and the resources to think. I don't want you just pushing buttons and running through the keyboard and throwing answers at people. I want you to think. And part of what we're trying to do with AI and the decision support tools we can build with it is to give our adjusters the best possible scope for thinking through these problems, understanding that with a complex claim, damn it, you've got somebody's life in your hands. If you don't do this right, they may not get to a proper resolution. They may not get the return to work support that they need. They may not get to the best hand specialist who can take care of their injury and actually get them back to being productive. How many people sit home right now with permanent degrees of disability because an adjuster was just processing them like they were a piece of meat? I don't ever want that to happen in any claim shop that I work with. I want my people to think and have the resources to think really well. And I want everybody to go home in a decent hour. I think that's kind of important too. So that actually didn't take quite as long as I thought it would, but it leaves us plenty of room for questions. So Cameron, I think you are looking at the question register, so I'd be happy to take any questions at this point.
Yes. There were a few people commenting on well, this is kind of scary, but kind of cool. No specific questions. So if people want to jump in and fire away in the chat, go for it.
Because if there are no questions, I'll just assume I did such a good job explaining this that everybody goes away knowing everything.
Well, I think one of the things that I appreciate is that you're not somebody who just got out of MIT at 23 with your PhD and don't know anything about how this world has evolved. And so that is wonderful. Okay, here's one. Has there been any thought around calculating wages? And that is a tricky question in time loss, I would assume, in the state of Washington, because there's some complex math that has to be done there. I'm sure AI could handle it, but thoughts on that?
Actually, that's a good question. That's something you don't really need AI to do that. It is a fussy business, and because each state has their own little twist on it. You know, life isn't complicated enough. Each state has to have its own complications, but that actually is the direct analog for calculating wages, oddly enough, is tax calculations, because it's the same type of step down, if this, then this, if this, then this, that is required to determine what a tax liability would be. That's a kind of application that we've been able to build for a long time. We don't really need AI for that. But
Okay.
a lot of claim systems, for one reason or another, have never taken the time to work that out because it's tedious. It is it's nothing but details. But that actually is a very straightforward programming problem. It just has a lot of, particularly in a state like Washington, it has a lot of recursions. If this, then this, but if not that, then you go over here, but then you go over to this chart over here kind of stuff. But yeah, you know, a modern, well-designed claim system actually should do that. There's no reason for it not to.
Okay, there's a question that says, I'm in the state fund, so someone who monitors the state fund retro, I believe. Is this similar to how the department determines the computer-generated reserves? That's a very specific question to L&I, but go ahead, opine on that.
Well, yeah. In fact, the first machine learning AI that I was involved with in my current position was a new reserving system. Did exactly that. And it was a machine learning system that basically looked at, literally thousands and thousands and thousands and thousands of claims by jurisdiction, um, and looked at all of the variables that impacted um, the final cost of a claim. Looked at thousands and thousands, obviously, of closed claims, so we knew what the answer to the question was, and then basically worked backwards to see what factors in the claim were associated with what outputs in terms of total claim cost. So that was the very first AI that we built. We had that up and running about 9 years ago. We're currently, I think it's in like release 12 at this point. Works very, very well. But machine learning AI is, in fact, very good at addressing exactly that kind of task.
Yeah, and I would say that going way, way back in the mid 90s, I had a stint at Travelers Insurance in claims down in Oregon, and they were introducing the first generation of, you're not writing down the reserves on a worksheet with your pencil or pen, but you're plugging it in, and the computer actually thought about the variables and then gave you a number given the age, the injury, and all of that. So I was kind of there at ground zero around that. And I think one thing that I recall from that is it kind of angered some of the older people who I thought older at the time. They're not older now in retrospect, but that it was so accurate, actually, even the first iteration, because it was just taking historical data and going, well, if X, then Y, basically.
Well, yeah, and I would point out, because I think you and I were at Travelers about the same time. It's a hell of an alumni club. Um, that when you look at how the human brain works, it's a marvelous machine, but the prefrontal lobes of the average human being cannot handle more than 7 variables at one time. And when you're trying to remember comps for similar claims to figure out how much of those things cost, if you're lucky and you're really good, you might remember 10. The system remembers thousands.
Right.
That's the difference. And because when you look at an AI reserving system, it really does exactly what your best adjuster would do, but it's got a much deeper memory, it's got a much bigger database to pull from, and it's got a far more rigorous capability of juggling variables in the process, but it really goes through the same process.
Mm-hmm. Gary, what about,
yeah,
I was going to ask, both at Gallagher and then maybe other organizations you're aware of, how has the uptake of, these first iterations of AI, how has that helped? I think you said the primary goal of an adjuster is to talk with injured workers,
yes.
with claimants, and to help them, because lack of communication causes litigation, causes all types of things. Have there been some studies in terms of how this is starting to positively impact that?
I don't know if there have been any completed studies. I know this is certainly something we are tracking data on it right now, but we don't, we haven't been doing this long enough to have what I would call convincing statistics. We do know that it definitely improves outcomes. We know that. I mean, for one thing, just ask adjusters. I mean, you know how reluctant adjusters are to complain about anything, right? So if you ask adjusters after we've gotten everybody used to this new way of doing things, of providing some decision support tools and for them, and so forth for them, ask them, do you feel that you're doing a better job? Are you getting to things on a more timely basis? And I think you can trust the answer you're going to get, because adjusters are nothing if not straightforward, shoot from um, the hip kinds of folks who are going to give you straight information. So anecdotally, yes, it's definitely working. Do we have a boxcar full of stats where we can say, we can take it down to a complete bell curve. Not yet, not yet. But we're working on that. Our own discipline at Gallagher Bassett is we try to measure everything. We're very big on metrics because that's the only way you know what you're doing. Everything else is anecdotal.
Correct. Correct. Any other questions from the group? Give them a bit of time. Yeah, I think one of the things that I've noticed in my career, Gary, is when I first started as an adjuster, I had my own claims assistant and file clerk at Safeco in 1990. That's how it was done. Technology came and actually kind of made the job worse for a while, but I think technology is now has the potential to make the job better. So you can, instead of just inputting data and not really touching or impacting not just claimants, but your employers, the other people that you work with daily. I think that doing the heavy lifting, the mindless work that AI can crank through quickly is great. So
well, you know what? One of my specialties in this area, I've given a lot of talks at things like the Predictive Analytics World Conferences and so forth, is what I call socializing the technobabble. And that is, however good the system is, it is no better than how it presents the final information to the end user, who is the adjuster. And in a lot of early systems, not enough thought was given to that. So the system did its job and it came up with a good answer, but it then would put it in a confusing format, where as an adjuster, you would look at it and you would say, what am I supposed to do with this? So we put, in the work that we do, we put a great deal of emphasis on, first of all, we don't change anything we don't have to. If we improve the system to give better results, we may use the same screen to deliver those results to the adjuster because they're used to it. It's kind of automatic. They just go to it. They know what everything means and where everything is, even though the system behind it changed completely. So that means there's virtually no learning curve at the adjuster level. Or we do everything we can to make certain that information like decision support systems and so forth is going to be, first of all, as reliable as possible. No false alarms, if to the extent that is at all possible. And that is delivered in the most usable, what I sometimes call most easily digestible form, because information is no more useful than the form in which it is delivered to the end user. And if you forget that, you start to lose a lot of the utility of what you're building.
yes, I agree. Well, folks, we are near the end, and from the lack of any other questions, a lot of people have been popping in saying that's great, this is exciting, and comments like that. So I think we are good. And by the way, for the good of the order, this is our third and final WSHA sponsored webinar for this year, unless we add another one, which I don't think we will. Gary, thank you so much for your time. Best of luck on your continued writing endeavors. So,
well, I'll be sure to let everybody know when The Last Train to Perdition comes out. That's my next Western.
excellent, excellent. Well, everyone, I hope you have an excellent day. And we will see you. The next big events, of course, we have the legal seminar coming up later this month in Tacoma. So take a look at our website for that. Also on, I believe, the 13th of this month, if you would like to be involved in our program for the remainder of 2023 and 2024, we're having an open session for people to give us their ideas on what we should be presenting, talking about, conferences, etc. So take a look at our website, see what's going on, and everyone have an excellent day. Again, Gary, thank you so much, and we'll catch up with all of you later.
Good deal.